right, so we have example, this is example 4. Yeah, this is example 4. All right, so we have the limit as x approaches 4, 1 over square root of x minus 1 over 2 divided by x minus 4. All right, so we're going to go ahead and simplify this and get in a form that is going to allow us to do something that is going to be new. All right, it's called a complex conjugate. We have to first get it to the point where we have a square root in the numerator and no fractions in the top. Okay, so let's first take care of this fraction. So we have a fraction here, so I'm going to use the pyramid method. That's 1 times 2, which is 2. Keep the middle sign, which is minus. Square root of 2 times 1 is square root of x, square root of x, over square root of x times 2, 2 times square root of x, over x minus 4. Okay, so if you have a denominator on top of a denominator, then these two become multiples of each other. So it's just going to be 2 minus square root of x are multiplied by each other over 2 times square root of x times x minus 4. All right, so that's just some algebra. All right, let me bring this over here. And again, the limit is as x approaches 4. Excuse me if I left that out. 2 minus square root of x over 2 square root of x times x minus 4. All right, so now we're going to take the complex conjugate. So the complex conjugate is just the multiple divided by the opposite of this numerator. And you know you can do the complex conjugates because you have the square root in the numerator and it's some type of fraction. And what's going to happen is that some of these factors are going to cancel, and then we're going to be able to plug in our limit and see how our function is behaving. Okay, so the complex conjugate again is just the opposite of the numerator. So the opposite of 2 minus square root of x is 2 plus square root of x over 2 plus square root of x. All right, and now we're just going to use FOIL. We're going to multiply this. All right, so we're going to do 2 times 2, which is 4. 2 times square root of x is plus 2 square root of x. Negative square root of x times 2 is negative 2 times square root of x minus x, because square root times square root is 1/2 plus 1/2, which is 1. So the exponent of that is going to be 1, which is just x, because the square root goes away pretty much, over 2 times square root of x times x minus 4 times 2 plus square root of x. And usually you don't have to FOIL the bottom because one of these factors are going to cross out. So let's see what we have here at the top. So I have 2 square root of x minus 2 square root of x. So we know that that is going to cancel. So I'm going to get 4 minus x divided by 2 square root of x times x minus 4 times 2 plus square root of x equals, so I have x minus 4. How do I invert this? I just factor out a negative, and then the 4 is going to become a negative. So it's going to be minus x minus 4. And if you need to prove that, all you do is just distribute a negative in. Negative times x is negative x. Negative x times negative 4 is positive 4. Over 2 square root of x times x minus 4 times 2 plus square root of x. All right, now we see that the x minus 4's cross out. So now we have negative 1 over 2 square root of x times 2 plus square root of x. Okay, so now we can plug in our limit. We get some more room. And it's bad that I'm not rewriting the limit of x plus 4. So make sure whenever you start a new line, always start off with the limit of x as it approaches 4. So negative 1 over 2 times square root of x times 2 plus square root of x. So if I plug in the 4, I'm going to have negative 1 over 2 times square root of 4 times 2 plus the square root of 4. All right, and let's simplify this. Negative 1 over 2 times square root of 4 is going to be, square root of 4 is 2, so 2 times 2 is 4 times 2 plus 2, which is 4. So you have 4 times 4. And you should get negative 1/16. So the limit as x approaches 4 of 1 over x square root of x minus 1/2 over x minus 4 is negative 1/16. Cool. All right, let's do another problem. All right, we have the limit as x approaches 9, square root of x minus 3 over x minus 9 times square root of x plus 3 over x plus 3. And actually the question is, this is actually the question right here. I already started the question. All right, so what you're going to do is you're going to take the complex conjugate. You know you have to take the complex conjugate because you have a square root in the numerator. So you're going to do square root of x plus 3 over the square root of x plus 3. All right, and just like the last one, we're going to not FOIL the bottom. We're just going to FOIL the top. So you're going to get x square root of x times square root of x. Square root of x times 3 is plus 3 times square root of x. Negative 3 times square root of x is minus 3 square root of x. And then negative 3 times 3 is negative 9 over x minus 9 times square root of x plus 3. All right, so we know that 3 times square root of x minus 3 times square root of x is 0. So we're going to get x minus 9 over x minus 9 times square root of x plus 3. And we see that the x minus 9 and x minus 9 is going to cross out. So we're going to do 1 over square root of x plus 3. So the limit as x approaches 9 of 1 over square root of x plus 3 is going to be 1 over square root of 9 plus 3, 1 over 3 plus 3, because square root of 9 is 3, 1 over 9. So the limit as x approaches 9 of square root of x minus 3 over x minus 9 is 1 over 9. Thank you. Oh, excuse me. 3 plus 3 is 6, not 9. All right, perfect. Thank you.